Hey guys, I want you to go ahead and start by taking a look at this problem right here and deciding which statement is true about these parallel lines crossed by this transversal. Okay, let's take a look at it and see how we did. So we can see, let me change up my pen here really quick. All right, so we can see that the first statement says 1 is equal to 8 and 3 is equal to 4. So that's comparing this one and 8 and 3 and 4. Okay, now when I look at this right away, just by looking at it, I can tell that 3 and 4 are not equivalent to each other because they are adjacent and they are forming a straight line, which means they are supplementary. So 3 cannot be equal to 4. 3 plus 4 would make 180. So I know answer choice A is out. All right. Let's take a look at the second choice, 7 equal to 2. So that's looking at 7, looking at 2, 1 and 6. Okay, so by looking at this one, I can see that 7 is equal to 6 because they are vertical, and 6 is equal to 2 because they are corresponding. But as far as 6 being equal to 1, if 6 is equal to 2's measure, then it cannot be equivalent to the one that forms the straight line with it because 1 and 2 are in a supplementary relationship. So that means this answer choice is also out. Okay, so let's take a look at letter C. We're talking about 4 and 5. Okay, and then 5 being equal also to 8. So if I look at this right now, I know I can look at this a couple of different ways. I know that 5 and 8 are definitely equal to each other because they are vertical angles. I have to figure out now if 4 and 5 or 4 and 8 are the same because I know already that 5 and 8 are the same. Well, when I look at this picture, if I took 4 and slid it down on top of 8, they would be corresponding, which means 4 and 8 are congruent. 8 is congruent to 5, so all three of these are equal to each other. So that means that 4 is equal to 5 and 5 is equal to 8. So I have found my answer. Okay, so today what we're going to talk about is we're going to talk about what to do with a picture that looks like this. So when I first look at it, I'm thinking, ugh, this is really complicated. I have no idea what to do with it. How am I ever going to find all of those angle measures? All right, so I'm going to show you a strategy for how to break down a picture that looks like this and how to find all those missing angle measures. So let's first talk about the strategy for this. So if you have a figure with one or more transversals, so again, remembering that this is a transversal and this is a transversal over here, and a pair of parallel lines, okay, or you could even have more than one set of parallel lines. The trick is to highlight one pair of the parallel lines and one of the transversals at a time, and then you fill in the angles that are made with those three lines. So I have to give you, or the problem has to give you, at least one angle measure in order to be able to fill in any of the angle measures, right? So when I look at this picture right here, I can see that I have angle 2's measure is 120. I have gone ahead and highlighted in blue the parallel lines and the transversal that I want to look at. And now I'm only going to look at the angles that are created by these blue lines. So I'm basically ignoring this transversal right here and any lines that are created with it. All right, so let's take a look here. So I know, first of all, that I'm going to handle all the vertical angles, right? So I know I've got 120 here and 3 is going to be vertical. So I know I'm going to have another 120-degree angle. Okay, so I'm going to have another 120 there. Okay, and let's see, if I know that this one is 120 and this one is 120, then I can find out what 1 and 4 are. And the reason I can find that out is because these angles form a straight line together, right? So if 1 and 2 are sharing a side, they're adjacent and they're forming a straight line, it means they're supplementary, which means that 1 plus 2 equals 180, which looks really weird now that I'm writing it. Angle 1 and angle 2 equal 180, all right? So all I need to do is take 180 minus 120, and that will give me the remaining angle measure that makes up the entire supplementary angle pair, and that is obviously going to be 60. All right, so what I know is that right here, I have a 60-degree angle, and if this one is a 60-degree angle, then so is this one. Okay, so this is great. I've got my first big set of parallel lines and transversal angle using the relationships, okay? Now what I also know is that down here, 11 and 1 are corresponding, right? Because if I take this angle 1 and I slide it down on top of angle 11, those two are going to have the same angle measure. So I found another angle measure, and that angle measure is going to be 60. Now, if 11 is 60, I should have a vertical angle that is 60, and here it is right here at 14. Oftentimes, students will make the mistake of choosing one of these angles, 9 or 13, to be vertical. Just remember, it has to be angles that are created by the intersection of these blue lines right here. 13 and 9 don't even exist to us right now individually because they are not being created specifically by these intersections of these blue lines. So 14 has to be our vertical angle. Awesome. Okay, so now I've got all of these, which is really helping me out. Okay, so this is about as far as I can go with this particular picture. I can see that I still have 12 and 13, I have 10 and 9, and then I've got this whole area to capture over here. So what I'm going to do is I'm going to do the exact same thing again, but I'm going to do it with the other transversal. So now I've highlighted the lines again in green, and I've got my other transversal over here, and I'm going to do the same thing. So I've been given angle measure for 7, which is 55 degrees. Again, I find my vertical, which is this guy right here. I'm going to dump this one in. Oops, I don't want it to be red though. Let's change my color here to purple. I like purple. Okay, so that one's going to be 55. Perfect. So now again, I can use my supplementary relationship to figure out what 5 is going to be. And again, I'm doing that by doing 180 minus 55 to find my remaining angle, which is going to be 125. And once again, I'm going to change this to purple. Oh, thought I was going to change it to purple. Heyo. Okay, so that means that this guy right here has to be 125. I'll go ahead and select purple right from the get-go. All right. Whoop. All right, so this guy's 125, and if this one and this one are vertical, then this guy has to be 125. All right, I'm getting much closer to having my picture filled out here. I've got this whole section taken care of now. All right, so now I'm going to do the same thing I did last time. If I look at what I have as far as corresponding angles go, I can see that 6 right here. Well, I'm going to slide down here to 9, and those two are corresponding angles. So I'm going to be able to put a 55 right here next to 9. And if this guy is 55, then the vertical angle to 55 is 12. So I'm going to be able to put my 55 over here at 12 as well. Okay. So thinking back between where we left off, we had 1, 2, 3, and 4. We had 11 and 14. Now we have 5, 6, 7, and 8. We have 9 and 12. So what we're missing right now is 10 and 13. So I want to take a look at something. Do you see the shape that's created by this intersection of these transversals with the parallel lines? It actually creates a triangle. Okay, so what we have operating here is a theorem that we might be familiar with. It's called the interior angles angle sum theorem. Okay, and it's referring to the interior or inside angles of a triangle. The inside angles of a triangle, I'm going to make sure my color is right again. I want this purple. Why can't I find that pinky purple that I want? Oh, that's all right. We'll use black. Okay, so the inside angles of a triangle add up to 180 degrees. That is what our theorem says. All right. So if I know that that's true, and that may be a theorem that you guys are familiar with, then that means if I have this interior angle, inside angle, and this interior angle, then I can figure out what the remaining interior angle is. How do I do that? I'm going with my 180 again, right? So I'm going to do 180 minus the 60 minus the 55, and that's going to give me the remaining amount, which is 65. So then down here, I'm going to be able to put in a 65. All right, so now I've got angle 10, which is awesome because I need angle 13 also. And if you look, what is the relationship between angle 10 and angle 13? They're vertical, so that means they're equal to each other. So I'm going to put that 65 down here as well. And now I have all of the angles for my double transversals.